was talking about frequency shift keying. We have discussed about frequency shift keying in today's class. And what is frequency shift keying? It is analogous to ASK, which is amplitude shift keying. In ASK, we have changed the amplitude of the carrier wave according to the massive signal, which was a binary signal or digital signal. But here in FSK, we will be changing the frequency of the carrier according to the massive signal. How are we going to do through that process? Let me show you practically. Okay, so the upper waveform is your input binary sequence or digital data which you have to transmit through the conventional analog channel. And we have a carrier signal which is a high frequency sinusoidal or cosine wave. You can take any of these signals. Now, in case of FSK, whenever the amplitude of the binary sequence is high or positive, whenever the binary input is high or positive, the frequency of the modulated wave will be high. This you can see, I'll show you through annotation. So whenever the input, your binary signal is high, the frequency is high. Let's say this is a frequency, it is denoted by F2. It is some frequency shown by F2. And when when the when the binary data is low, when your input sequence is zero, when the input sequence is zero, the carrier has got a different frequency, which is F2, yeah, sorry, F1. Okay, so there are two frequency components. One is F1, other is F2, and they are used in such a way that when the binary data is high, when the input massive signal is high, the frequency is high. When the input signal is zero or low, the frequency is low. This you can easily see from the waveform that the number of cycles in F2 are much more than the number of cycles shown in F1. Is that clear, Vandana?
Yes, ma'am, it's clear.
Is this clear that F1 is less than F2? Can everybody see this? That F1 is less than F2? It is based on the number of cycles. So the number of cycles in F1 are less than the number of cycles in F2. Or we can take vice versa also. It is not mandatory that every time whenever the binary data is high or positive, we have to take high frequency, or whenever the binary data is low, we have to take low frequency. It is not means mandatory. We can take a vice versa condition also, where whenever the binary data is high, we can take a low frequency, and whenever the binary data is low, we can take a high frequency. That's up to us, but most commonly, conventionally, for high binary input, for positive binary data, we take a frequency which is high, and for low binary data or zero mode, we take a relatively low frequency. So this is how we distinguish or we modulate our carrier wave by changing the frequency in accordance with the massive signal. Right? Is this clear to everyone? So in
Yes, ma'am.
case of FSK modulated wave, what are we doing? We are changing the frequency of the carrier in such a way that whenever the binary input or massive signal is high, the frequency is high, and whenever the binary data is low, the frequency is low. Is that clear to everyone? I hope this concept is clear, and we, that is how we obtain frequency shift keyed modulated output waveform as shown here. So after we have got this process completed, this is the basic concept of FSK. Now I will tell you about the block diagram or transmitter of FSK, the receiver or demodulator, and its various properties and features. Okay, so let's go to the next slide. Okay, so this is the block diagram of FSK transmitter. Here we are using two oscillators producing two different frequencies, F1 and F2, where we can think that F1 is less than F2. I'm so sorry, let me see which was great. F1 is less than F2, fine. So as per the previous waveforms, we can see that F1 was less than F2. So let us take two oscillators having two different frequencies, F1 and F2, where F1 is less than F2. Now there is a switch, and to this signal the binary message signal is arriving here. So whenever the binary data is high, whenever the binary message is high or message signal is high, the switch will be closed in such a way so that the high frequency signal is passed. Let's say the high frequency signal is F2. Yeah, high frequency signal is F2. Now, when the binary message signal is low, the switch is connected to the upper oscillator, which is F1. So the switch keeps on toggling, changing between F1 and F2 based on based on your input binary message, and hence the output is the FSK modulated wave. Is this concept clear to everyone? Is this concept clear to everyone? So this is how we obtain frequency shift key. Okay.